Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
There we go. So, tutorial 197 uploaded, where we did our first classification using the semi-automatic classification plugin, and we discovered some nice features. Well, let's start with the three not so nice, which is that there's three methods that we can't perform, but I think they are not the most widely used ones. So the ones that we can perform, that are actually the ones that I would like to perform. And then, yeah, we performed three classifications, and then we did the sieve, which is a very, very neat feature, unique to this method. Something that I would really suggest you apply and you use. Anyway. So we're gonna next this video we're gonna play around a little bit and see what else we can figure out from this plugin. What else lies around the corner, so to speak? What other hidden gems are there? Because I think there's much more. Okay, so thank you very much for your loyalty and your support for this channel. It's unbelievable, 225 videos in a year. I think that's quite a lot. I think that's a good achievement. Almost 1,700 subscribers. I think that's also good. But now, as I said, the watch time. I need to get those hours up. Please, please, please. Do me a favor. Just go to the channel, go to a playlist, put the playlist on, put it on loop, forget about it, and let's build those hours, please. I'll really appreciate it. I need to get those hours up. We are on our way, but we're not there yet. We need to get those hours. So it's a plea from my side. Yeah, thanks. So, okay, so let's play around. So we go back, and there is our sieve and our non-sieve classification using the multi-layer. Let me just confirm what it's called, the correct word of it. Band processing classification, the multi-layer perceptron method. Okay, so there it is. That's that classification, and then the sieve. Go into my previous video tutorial, you see what the purpose of the sieve is, and to a large extent is to clean up your classification. Okay, so more details in there. But on this, while we're there, if we go into the sieve window, you can see there is some options here, specifically the panel connection, the 4 and the 8. So I'm going to leave this. So remember, what I want to do is I want to go and do a sieve of this particular classification. I did a sieve here, which is based on the 2 pixel connection. Okay, so let's quickly do an 8 and see what the difference is. But first of all, make sure we've got the right band collection. So if we go to sieve now, you'll see it will perform it on band 3. Now, to find out what band 3 is this neural network one. So we don't want to do it on that one, we want to do it on the sieve. So I double click on the sieve. So this actual display here, band set 2. Okay, and then I go to my sieve here and I change it to band set 2. So now I'm saying I want to perform a sieve on that specific classification. I leave that as 2 and I'm changing this to 8. And I'm just going to make a little 8 here so that we know which one is it. And then I simply just click run. And I select the folder, which is fine, and then it will run. I should actually just should be done. Let me just see if I can make it a bit smaller. It's done. Okay, so there it is. There's my sieve. Okay, so let's just quickly get the style sorted. So load style, and I'm going to go into Remember, I've loaded the semi-automatic classification plugin. Um, uh, which one is this? This one here. Style. So I select it, load style, close, close, apply, close. Okay, and there it is. Okay, so now we've got the actual classification image. The classification image, we've got the sieve image with the 4-pixel connection. And now here we've got the sieve. That's a sieve with a 4-pixel. And here we've got the sieve with the 8-pixel connection. There we go. So there's with the 8-pixel connections. Okay, so let's quickly locate a place and then zoom in and see what the difference is. Let's quickly go and have a look and see what this looks like. Okay, so that's the raw image, the classification. And remember, the idea of the sieve is to identify these outliers and then to merge them with the majority area around it, okay, with the classification around it. So this indicates mountain, which doesn't make sense. So the program will realize this is outlier and it will merge it within the surrounding area, which is veld. So that's exactly what the sieve did. You see now it's gone. That's the 4-pixel connection, the 4-pixel connection. And if we go to 8, you'll see it's still missing. However, you can see there's more of these connections. Because what the 8 does, it looks further. So let's say, okay, so let's go back there, that one there. So the 4 only looks at its immediate vicinity to merge it or to blend it or to harmonize it. Harmonize, I would think, is a better word. Huh? I think harmonize. Let's go with harmonize. To harmonize it with it. If you go 8, it goes further. So it most probably would also look at something like this, and therefore it will not be as clean as the 4. You see, there's the 4. Okay. There's the original one, and there's the 8. You can see the 8 does take stuff away, but it's not as clean. So you can see, for example, this one here. Okay. So there's the original. It's got this pixel here, which indicates, let me zoom in, this one here. Let's zoom. So with the 2, it disappears because the 4-pixel, because it only looks at its immediate vicinity. But with the 8, it stays there because it also takes into account this area. Okay, so I would select the 4 because the 4 is much cleaner than the 8. But then again, that's my view. That's something that you can try to figure out. So that's just to give you an idea of the difference between the 4-pixel connection and 8-pixel connection. The 4, harmonize it with its immediate pixels around it. And the 8 is, it goes a bit further. It takes the harmonization or the area that it considers for the harmonization a bit further and stuff. So if the 8 would not necessarily as clean, in inverted commas, again, it's not the right word, but I hope you get the idea, where the 4 is much cleaner, much more effective in my view. So that's the sieve that we do for now. The threshold size, so let's make it a 10 threshold size and let's keep it a 4. And I'm going to keep it the 4 as under, and then I'm just going to make it 4 and underscore 10. And then let's run it and see what that does. So I'm keeping that pixel connection 4. I'm keeping the band 2. Remember, always watch this. So to make sure that you have the correct band that you're going to perform the sieve on, and I call it that. Make it big. So there's an obvious difference, if there's any difference. So let's run it. And let's say select folder and let's run it. It should go quick. There we go. So let's minimize it. Okay, so that is the 4 sieve. Okay, so let's quickly get the style going, load style. Let's wait for it to, okay, there we go. So where is it? There we go. Open, load style, close, close. Okay. Okay, so there is the 10. So it's actually, okay, so that's actually even not, still cleaner. You can see there's a big difference, huh? So there's the sieve 4 and there's the 10. It actually, okay, so let's zoom in again. It actually cleans it up even more. So there's just the 4 with the 0 threshold. There's the 4 without the 0 threshold, and there's it with the 0s. You can see it even takes these ones away, which, yeah. So even those ones that are surrounded, that's in the middle of nowhere, so to speak, that's not harmonized, it takes them away. So it cleans it up even more. So let's compare to the original. There's the original one, and there's the sieve with the 10 threshold. That looks much, much better. You can see it actually cleans it up massively. You can see that. That's big, big difference. Look at all this red, which is sand, by the way. Look at all this red. And if I do the sieve, it just takes it away and it becomes red all the way. Let's make sure there's nothing there. Let's just make sure. Okay, so that. Okay, so that's it. Let's see if yeah, it just takes all of that stuff away. Huh? So that is actually even better, if you ask me. So that's the original one. That's the original one. That's the original one. That's a C4 without a threshold. That is a C8 without a threshold. And that is the C4 with a 10 threshold, which is massive. Huh? That's a big difference. So it takes all those, I don't want to say outliers, but all those ambiguous ones that sort of is, I wouldn't say necessarily a misspecification, let me put it this way. It cleans up this thing much, much better because, yeah, so that seems, yeah, that's very, very different. That's very, very different. Sand area, felt, urban. There's still some mismatch with the urban, but not as much. And this, I think, this mismatch with the urban and the felt, we can sort out if we do those overlaps. If we delete those two, that's maybe what we can do next time. Is you remember those two outliers? If we go into this signature, the spectral signature plot. Okay, I haven't highlighted them. Let's quickly highlight them again. Do I have all of them? If I go, well, let's just do the urban. It was the urban where we had the issue. Farming, let's just check that mountain, felt. I want to take that out. Urban. If we do the spectral plot, spectral signature plot, you can see that if we take these two out, 8 and 9, I think was it 8? Yeah, 8 and 9, 8 and 9. If we take 8 and 9 out, what will the impact be? Because that signature, spectral signature, seems out of place compared to the others, and that's because it's a mine that I've put as an urban area. So its spectral signature would obviously be very different to a normal suburb or one of the normal towns because it is a mine. So that's one can practically justify why that signature, spectral signature of those two urban areas are different to my other urban areas, because in reality it is different. So the spectral signature bears that out. So if we delete those two, it may be quite different. So what we can now do is to say, okay, figure out where there's potential overlaps and go into those signatures or those samples where there's overlap and delete them or adjust them or change them, whatever the case might be. But anyway, so that seems quite good. So let's go into the method itself. So that's this multi layer perception. We had the scikit-learn, we have, and then there's a PyTrack framework. So these are the normal, um, or the default parameters. So let's leave it as default and let's click the cross-validation, find the best estimators with steps 5, and let's do calculate classification confidence raster. So let's tick these 3 parameters. The other parameters we leave exactly the same because I want to compare it with ones that we've already done. Okay, so make sure our band set in this case is 1 because it is our sentinel bands in order with the correct wavelength. So that we're happy with. Our macro class, we've already got them there. There are our macro classes. Our training file is loaded, so we've got that. We've leave all these parameters by default as the one that we've done. Just gonna put it there, and then we're gonna run it again. As I said, I've just added the history. I'm leaving 5 as the parameter, and we're gonna go again. This is semi-automatic classification plugin, and it's the layer that one there. Okay, so let's just quickly make sure I've got that, and then I'm just gonna go here and make a one here, and let's say it is modify. It's not modified per se, but it's because we've selected all these other ones. So I'll know that modify means select these ones, happy with the rest, and it will go into that one there, and we say save. It will run there. It will hopefully locate it there. So let's have a look and see what this brings. What happens now? Okay, so it's 5%. I presume it will take a bit longer because it has to do all these other things. There's maximum iterations is 200. Training portion is 90%. Learning rate is whatever that means, alpha. Activation, we'll go and have a look and see what these options are now once it's just done. So let's just give it a bit of time. I'm sure it is running at the background like crazy. So remember, this 5% is normally our benchmark. If it goes over the 5%, cool. Otherwise, at 5%, it will give you a error. But hopefully, it should work. It's processing. It's processing. Cross-validation, find best estimator with steps 5, calculate classification. We obviously compare it with the original one and see if there's any improvement. And then obviously, if there's improvement, we can again apply the seeve, etc., etc. So this process is an iteration process. You start from a very basic base, and then you start adapting, changing, modifying, etc., etc. So it's basically trial and error the whole time, which is time consuming, but it's definitely very exciting and worthwhile. And this is why you can see now why this is um, the most widely used classification method in my book anyway, my view, my perception. I might be totally wrong, but I think this is the most widely because it is fun and it's interesting and it's easy. It's time consuming, it's frustrating because it just goes on and on and on, but it is very, very fulfilling. It's very interesting. And I said, just the ability to to optimize your training samples. That already is, because that's where most of these things fall flat. Most of these classifications fall flat because your training samples are not unique. Their spectral signatures are not unique. So if your spectral signatures are not unique, then you're going to have overlaps and you're going to have confusion. So this one is still going. So let me quickly pause there, and then I'll be right back as soon as this thing is completed. I don't want to waste your time. So let me quickly pause, and I'll be back as soon as this is done. It seems it is, eventually it's done. To be honest, it took a long time. I can't remember exactly because I switched it off when I went home and this morning. So I left it overnight and it's done. So, and I think it's because of all these tabs that it is a little bit, that it took so long. The initial image without the tabs, I think took about a minute, 2 minutes. This one, I think with these functions took a long time. So let's have a look and see what the map looks like. So this is the one, the new one that we just generated. So let's quickly have a look and see. Let's quickly do the style, load style. Okay, now let's quickly just wait for the style to load quickly, then we'll add it. I need to sort out this folder. It's becoming a mess. Anyway, there's just the style. Let's add it, load style. And there it is. There should be no difference between it and the original. There's the original one. There should, oh, there is a difference. Why is there a difference? There's indeed a difference. I think it's because we did the training. There is a difference. There is a bit of a difference, and it's mostly to do with the veld and the urban areas. You can see there, for example, there. It's got more urban areas than veld. Anyway, so let's have a look and see what this one is. Because remember, these were also loaded now, these three ones. Let's have a look and see. So these three ones is also loaded. So let's have a look and see what they are. So it's a cross-validation, first best estimator with slopes, calculate classification confidence raster. Now where is these ones? Support, okay, that, I don't know where it would have loaded it. Because this is a new one that was loaded, support vector. 1 RFB. Okay, so that's not it. What is this one here? Okay, so that's also so I'm not sure exactly where it goes. Because let's go and have a look and see in the folder. Let's just update it. No, it's not there either. You can see there's the classification images. There's the modification one. So I don't know what it would have done with that one, with these functions. I really don't know. I need to go and find out. The training program, so that could be why there's a bit, no, but that was on the original one as well. Cross-validation, find best estimator with steps 5 says calculate. So I presume they've done all, this is part of the training program, so they've done all this and they generated this new image, because we called it modification. These other ones, there's no others that were done. Doesn't look like it. So, well, it took a long time to generate this, and this I would think, well, it doesn't look better than the original one. To be perfectly honest, the original one without it looks better than this one, the modified one, to be very honest. I can't, yeah. It definitely looks, yeah, no, this the original one looks better. This modified one doesn't do it for me. So I'm not sure what the point of these ones was. Um, let's have a look and see what. Okay, so that is it. Alpha maximum is a hidden path, and then there's a pipe track. Okay, so let's have a look and see what that does. Keep all of them exactly the same. I'm going to take these off because it takes a long time. So let's quickly run it and see how that looks. So this is part of the game that we play, or part of the fun part of it. You just change the parameters and see what the outcome is. So this one will be SCP, and then classification is also mult. Let me just quickly check some of this one. But we're using not the ciclet, we're using the PyTorch. PyTorch. And it's still 100. It's still 100. The rest of it stays exactly the same. And let's say save. It should run. Let's see if it goes past. Remember this, the 5%, the 5%. We get past the 5%. Yep, failed. I don't know why it failed, but it failed. I'm not sure whether it is because it ran so long overnight. Um, let's have a look and see what's in the random forest. We'll come back to it. We'll try it again and see if it works. But if not that, hidden layers, let's make it 500 and see what it makes. So I'm going to leave everything exactly the same. The training, the learning rate, all these things I'm going to leave the same. So let's quickly do image classification, ciclet, and this is going to be the 500. Not 5,500. Let's see. See if it works now. I've got a suspicion I have to restart. Let's see if it goes past 5%. If it goes past 5%, then I don't have to restart. It's not a restart issue. It's taking again a bit of time, but at least it's not throwing me an error, so I think it's going to run. Let's hope so. Let's hope so. Let's hope so. There we go. 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 Okay, so let's quickly have a look and see. So I'm gonna just need to go and do the styles, load style. And okay, let's wait. Remember, once I've done all my images, I'm gonna do the unique values report for each of them. And then I'm gonna complete my Excel spreadsheet and then compare. So there's that one there. Let's go load style. Okay, close and okay. And there it is. So let's have a look and see how it compares to the original one. Also, remember I haven't done the sieve, so we compared with the original one. You see there's some red there. I'm looking at this part here specifically. You can see there's more red, and you see there's less red, which is urban areas. So we want less urban areas. There's no urban areas there. Okay, so last one before we say tata for this episode. Let's make it 10 and see what, because it seems if we're higher, it seems less accurate. So let's make it 10. And then let's have a look. I'm going to end this video on the 10. Let's save. Okay, let's go on. So there's two things that we still need to do. I said I need to do the general. I think we've done most of the image classifications that I wanted to do. And then I'm just going to do unique layer report for each of those classifications. And then I'll do my Excel report. And then we're going to play around in Excel. And then after that, we need to do the post processing, specifically the accuracy report, because that's also very, very nice. But before we're going to do the accuracy, we're going to do the sieve of each one, because in the accurate post processing, we're going to use the sieved layers, because we know that there's more accurate. Okay, anyway, so let's go back into this. We've done it now. So let's have a look and see what that looks now. Properties, the style, and we're gonna go. Okay, let's give it some time. Um, okay, there it. Nope, there it is. And go load style. Close. And this looks better. Indeed, it looks better. Definitely much better. So, um, hidden layers, lower values better than higher values. Lower levels, less misspecification than higher levels. And obviously we can now play around with these other ones, but I'm not going to play around. I'm just going to do one of each, a basic one, and I'm going to do the sieve of each of those ones. And then I'm going to do the unique layer report, and then we're going to do an Excel and see what we find. And that should then end our series on pixel-based and pixel signature-based image classifications. But remember, there's still object-based classifications that we're also gonna have a look at. So there's two. We'll get to that. Let me not hana further. Okay. So thank you. I hope you enjoyed it. It's fun. I really enjoy this. It's time consuming, but it's really worthwhile, and you learn quite a lot. So yeah, thank you. Okay, cool. So with that said, I'll see you on the other side.